Hey guys, in this lesson we're going to be taking a look at arc lengths and arc measure. So to start off with, arc measure is how much of a circle in degrees, or how much of a circle is intercepted by an angle. So if we're looking at the central angle right here, and it's got to be a central angle. So let's say this is 32 degrees. The central angle is 32 degrees, then PQ is going to be 32 degrees. So you could say that the measure of arc PQ is going to be equal to 32 degrees in this case. And the angle POQ is going to be equal to the measure of arc PQ. And then they could also ask you to find the arc of that measure right there. And circles altogether are 360 degrees. So you do 360 minus the 32, and that's going to give you 328 degrees. So if you go from there to there, that way, it's going to be 328 degrees. They could also ask you about arc length. And whenever you're looking at arc length, it's a portion of the circumference of a circle. So if you were to take a ruler and find the length of that arc, that's kind of like what they're doing. And so when they're doing a portion of their circumference, remember circumference is equal to 2 pi r, and that'll give you the distance all the way around, or the length all the way around. But whenever we're doing arc length, we're not doing the whole distance all the way around, we're only doing a portion of it. So we've got to figure out how much of that circle we actually have. So we're going to multiply it by a fraction. So we're looking at what part we have over the total possible. So if we look for the total possible in a circle is going to be 360 degrees. So this angle that they have there, or theta, that is the Greek letter theta. And it's just used to represent degrees. So all those times we were doing those trig functions and we were using the sine of A or the cosine of A or the tangent of A, we could have also been using the sine of theta, the cosine of theta, or the tangent of theta. It's a variable that they like to use in trig for degrees. So if we're looking for arc length, or a portion of their circumference, we'll do 2 pi r times the fraction of the circle that we have that we're actually working with. Okay? So if we start trying these out, we're going to start off with a couple examples on arc measure. So for arc measure, they want to know what is the measure of arc GH. So if we look, arc GH goes from there to there. And if we look at all the other values they give us, they tell us that this arc from I to H is 87, and then F to I is 86, and then F to G is 59. So they give us all of the arc measures except this one right here. So if we took all of these arc measures and added them all together, it'd be equal to 360 degrees. So we can write that down. We can say the measure of arc FG plus the measure of arc GH plus the measure of arc HI plus the measure of arc IF, and that puts us back at the beginning, is going to be equal to 360 degrees. So FG is 59 plus GH we don't know, so I'm going to leave it the measure of GH plus HI is 87 plus IF is 86 is equal to 360 degrees. So now we can combine our like terms. So 59 plus 87 plus 86 is going to give us 232 plus the measure of arc GH is going to be equal to 360 degrees. Subtract the 232 from both sides, and the measure of arc GH is going to be equal to 128 degrees. So that tells us from there to there we have 128. So that's one way they could ask us about arc measures. Another question that they could ask us about arc measures is they could still ask us to find the measure of the arc. They could also ask us to find x. In this case, they want to know what is the measure of RS. So if we go and we find RS, there's RS, and then there's RS there. If we look, RS is equal to 14x plus 71. And in order to be able to say what the measure of RS is going to be, we have to know what x is. Well, in order to be able to know what x is, we have to solve for it. So if we look, all these values right here make up the entire outside of a circle. And we know an entire outside of a circle is equal to 360 degrees. So we can take arc PS plus the measure of arc SR plus the measure of arc RQ plus the measure of arc QP, and that'll put us back at PS, is going to be equal to 360 degrees. So if we replace the names of the arcs with the values that we have, PS is going to be equal to x plus 90 plus SR is the 14x plus 71 plus 100 plus 18x is going to be equal to 360 degrees. And again, I got all of these measurements from their parts on the circle. So now we need to combine like terms. And we get 33x is equal to, combine the whole numbers, so this should be plus 261 is going to be equal to 360 degrees. Subtract the 261 from both sides, and we get 33x is equal to 99. Divide both sides by 33, and we get x is equal to 3. Now you got to be careful. You will get some questions that it just ask you to solve for x, and then you'll get others like this one that ask for what is the measure of RS. So be very careful with what the question's asking and make sure you answer what it's asking for. So in this case, they want RS. So we know RS is equal to 14 times x plus 71. So the measure of arc RS is going to be equal to 14 times 3 plus 71. So the measure of RS is going to be equal to 14 times 3 plus 71 is going to give us 113 degrees is our measure of RS. So that's an example of some of the things that they could ask you to do with arc measure. They're just keeping it to the outside of the circle and knowing that the definition is 360 degrees. Now getting into the next type of example, these are the ones where they start getting into arc length and having you solve for arc length. So if we go back here, arc length is a portion of the length of the circumference of a circle. So if we look, circumference is going to be equal to 2 pi r times theta over 360. And another way that you'll see this written is, instead of writing a c, because we're not finding the whole circumference, you'll see L is equal to 2 pi r times theta over 360. And the notation that you'll see for this is, let's say this was A and this was B. You'll see length of AB is equal to, and that's one way that you can see them asking you to solve for the arc length as opposed to the arc measure. So if we give these a try, they tell us that the radius of a circle is 5 kilometers. What is the length of a 135-degree arc? So if we're looking, they want the length or the measure, they want the length or the distance from this point right there all the way over to that part right there. So we're looking for, and I'm using the definition for the formula, the length is going to be equal to 2 pi r times theta over 360. So the values that we would need to have in order to be able to solve, we would need to have a theta and we would need to have a radius. So we're looking at the length of the arc is going to be equal to 2 pi times the radius. In this case is 5 times theta, which is 135 over 360. Now, I'm pretty sure that whenever they ask you to do these problems, they ask for exact answers. So that means we're not going to want to multiply by pi, and we're going to want to leave it in our answer. So with these, if it asks for exact, if it asks for an exact answer, you're going to have pi in the answer. So you're going to end up with, I don't know, 3/7 pi or 2 pi or 3.75 pi. Those are exact answers because they haven't multiplied the number in front by pi. Because remember, pi is a number that goes on for forever. So you're not going to be able to write down whatever the answer is for this because you would have to round at some point. And that's what they mean by exact, is they don't want you to round at any point at all. So by not multiplying by pi, you get the exact answer. If they ask for an approximate answer, then there's going to be no pi, and then you'll end up having to round. Okay, so be very careful and read exactly which one they're asking for. Okay. So for the ones that, the examples that I'm going to do an exact answer. Okay, so that means that we're going to have pi in all of our answers. So that means I'm never going to multiply through by pi. So I'm going to multiply the 2 times 5. So the length is going to be equal to 10 pi times, now 135 over 360 has to simplify. And if I put that in my calculator, I get 3 over 8. And remember, we don't want to multiply by pi, but we want it in simplest form as possible. So we can do 10 times 3/8. So I've got the 3/8 still in my calculator. I'm going to hit times 10. Gives me a mixed number, which I'm going to switch to an improper fraction. So I've got 15 over 4 pi. And that's the answer that you would want to put in. I'm pretty sure you could also put it in as a decimal. And you could do 3.75 pi. So as an exact answer, both of those answers are correct. So looking at the next one, doing another example. This one says the diameter of a circle is 14 miles. What is the length of a 90-degree arc? And we're looking for length of an arc. So that's how we know we're using this formula right here. The length of an arc is going to be equal to 2 pi r times theta over 360. So if I rewrite that, length of an arc is going to be equal to 2 pi r times theta over 360. So length is going to be equal to 2 pi times r. Remember, r stands for radius. And if you look at this problem says diameter. We're not interested in diameter, we need radius. And you remember from where we've talked before, radius is going to be equal to your diameter divided by 2. So your radius is going to be equal to 14 divided by 2. The radius for this problem is going to be 7. So I've got 2 pi times 7 times theta. Theta is our angle, and it says we're working with 90 degrees. So 90 over 360. And for this, they want an exact answer, so I'm not going to multiply by pi. But I am going to do 2 times 7. 2 times 7 is 14 pi times 90 over 360 is going to simplify down to 1/4. So now if I do 1/4 times 14, L is going to be equal to 14 over 4 pi, but that's not a good answer because that could be simplified. And if you simplify it, you'll end up with L is equal to 7/2 pi, or you can write it as a decimal and do 3.5 pi. Either way, don't forget to put pi into your answer, otherwise it'll be wrong. Okay. So that tells us that if we measure the length from this point right here to this point right there, it's going to be 3.5 pi. So these problems are very straightforward problems. They're asking you for either arc measure, and you just add them together, subtract them from 360, or they can give you arc length and you just use the formula to be able to solve. They could give you problems where using your arc length formula, they want you to find an angle measure. So looking for this one, it says the radius of a circle is 10 meters. What is the angle measure of an arc 3 pi meters long? And if you look, for every single one of these problems, it's going to ask us to find the angle measure. So we could use this formula every single time and end up solving for theta, or we could just take this formula, solve just this formula for the angle measure for theta, and then that'll save you a lot of multiplying and dividing work, and it'll be a lot shorter and easier. But if you forget this formula, you can get it from the arc length formula really easy. So if we're doing angle measure, using arc length, make sure you write this down. We were doing the arc length is going to be equal to 2 pi r times theta over 360. Well, if we're going to be solving for theta all the time, might as well get it by itself on one side of the equal sign. So the first thing that I did was I multiplied both sides by 360. That way I wouldn't have a fraction here. So multiply this by 360. And that'll leave us with 360L is equal to 2 pi r times theta. So theta is not all by itself on one side of the equal sign because it's being multiplied by 2 pi r. So if we divide both sides by 2 pi r, that'll leave us with 360L over 2 times pi times r will give us our theta. Now if you notice, we've got 360 over 2, and we can simplify that. 360 over 2 is going to give us 180 over pi times the length over the radius, and that's going to give us theta. So if you use that to solve for our problems, the radius of a circle is 10 meters. What is the angle measure of an arc 3 pi meters long? So I'm going to take this formula that we just came up with. Theta is going to be equal to 180 times L over pi times the radius. So if we do that, theta is going to be equal to 180 times the arc length. And here they tell us the arc length L is equal to 3 pi. So 180 times 3 pi over pi times the radius is going to be 10. So looking at this, the pi's are going to simplify automatically because pi over pi is going to give you a value of 1. And that's going to leave us with theta is going to be equal to 180 times 3 over 10. And you can simplify, multiply, divide, cancel, whatever way you want to do it. I'm just going to do 180 times 3 divided by 10. And that's going to give us theta is equal to 54 degrees. So they're asking us what is the angle measure of the arc that is 3 pi meters long, and this is going to be 54 degrees. Looking at the next one, the diameter of a circle is 10 kilometers. What is the angle measure of an arc that is 2 pi kilometers long? So they're looking for this angle measure right there. So if we do that, we're looking at theta is going to be equal to 180 times the length of the arc divided by pi times the radius. I'm just using that definition formula. So we're looking at theta is equal to 180 times our arc length is 2 pi over pi times, now it asks for radius. And here they don't give us a radius, they give us a diameter. So radius is equal to diameter divided by 2. So our radius is going to be equal to 10 divided by 2. Keep a close eye because they do switch back and forth between radius and diameter. So our radius for this problem is going to be 5. So we're going to do pi times 5. So to start simplifying things, pi over pi is going to be equal to 1. Theta is going to be equal to 306. Skip a step. (180) times 2 over 5, and if you multiply that out and divide it, 180 times 2 is 360 divided by 5 is going to be 72. So the measure of that angle right there is going to be 72 degrees. Now, if you look back, I feel like these are kind of misleading because when you're looking at theta, you're looking at the angle measure right here, and they're putting the 135 there, which is technically correct for the measure of the arc, but whenever you're using this theta as the angle measure, you're really using the angle measure here. So technically, whenever you're doing these problems, you're using this angle measure and not the measure of the arc. All right, so these were nice. They gave you pictures to work with. The next set that I have for you, they don't give you pictures. So if you're a person who needs pictures, just draw you a quick sketch and then you'll be good. So looking at this, the radius of a circle is 48 feet. So we're starting with a circle. So draw a circle and a radius is 48 feet. What is the angle measure of an arc that is 19 pi feet long? So I don't know for sure how long that arc's going to be, so I'm just going to kind of guess that it's going to be about this big. So we're looking for the arc length from there to there. It has a length of 19 pi, and this is also 48. And they want to know what is the angle measure, and for the angle measure I'm going to use theta because that's what we're solving for. So if I use that formula that we came up with on the other page, theta is going to be equal to 180 times your arc length over pi times the radius. So theta is going to be equal to 180 times the arc length, which is 19 pi, over pi times our radius. And our radius in this problem, and I'm double checking what the problem gave us, and it did give us 48 feet. So pi over pi is going to have a value of 1, and then I've got 180 times 19 over 48. So 180 times 19 divided by 48 is going to give us theta, or our angle, is going to be equal to 71.25 degrees. And that's the measure for that angle right there. Looking at the next one, they tell us we have a diameter of a circle is 50 centimeters. So drawing a circle, we have a diameter. Remember, a diameter means it goes through the center. So this whole thing is going to be 50 centimeters. What is the angle measure of an arc that is 13 pi centimeters? I don't know how big that is, so I'm just going to draw a guesstimate. So from there to there, the arc length is going to be 13 pi. And they want to know what is the angle measure. Angle measure, I'm going to use theta to represent it. So they're wanting us to solve for the angle. So theta is going to be equal to 180 times L over pi times the radius. So theta is going to be equal to 180 times the arc length is going to be 13 pi over pi times the radius. Now this time, double checking, this says diameter. We don't want a diameter, we want a radius. So our radius is equal to diameter divided by 2. So in this case, our diameter is 50 divided by 2. Our radius is going to be 25. So theta, 25 goes there. So pi over pi gives us a value of 1. So if we simplify that, that leaves us with 180 times 13 over 25. So 180 times 13 divided by 25 is going to give us a value of theta, or the angle, is going to be equal to 93.6 degrees. And you definitely could end up with whole numbers. It just so happens the examples I picked both came out to be decimals. So there's your 4 different examples of how to use your arc length formula to find the angle measure. And all we did was we took that arc length formula and solved it for theta so that we wouldn't have to be doing all the multiplying, dividing the whole time. It made our math a lot easier for us. And then we did a couple examples where we found the arc length using our formula. Arc length is equal to 2 pi r times theta over 360. And remember, for this section, they're wanting exact answers, so do not multiply through by pi. And then you'll have a couple questions that ask you about arc measure, where they ask you to find one of the arc measures, or they give you expressions to represent are the arc measures. You've got to solve for x, and then sometimes you'll have to tell them what the arc measure actually is. So if you have any questions, be sure to write them down on your guided notes and ask whenever you get to class.